Thank you, Ivona. And I see a friend in crime again, Dave Birch. Hello, hi. So I need to check how the slides are going to work. They come on here? The slides? Okay, yeah. So I was asked to talk about Internet of Things, security and privacy in 15 minutes. So that is hard, as you can imagine. But I'm going to focus on a specific aspect of this subject, and which is related to my research at Oxford and also the smart cities area. It also fits in very well with the CAMINO project. And the basic idea of my work is, as Ivona mentioned, I am involved in looking at data science for Internet of Things. So if you look at this whole idea of predictive analytics, applying those algorithms to IoT data, which include time series, sensor fusion, all that kind of thing, that's really what I do. So it's very mathematical in a way. The thing which I teach at Oxford has to do with IoT, the thing which I teach in Madrid has to do with smart cities, but the idea is the same, that you have data sets, you have IoT, you have predictive analytics, and in this case I'm going to talk about from a threat perspective, what can go wrong. And the course I have mentioned there, it is actually open to the public, which is just recently launched last week. It does provide an Oxford certification, so if you are interested in this subject, please follow me on Twitter, and there is a link to the Oxford University course. As you know, we have a lot of people from HyperCat to Mapar to Sigfox, all the people who we work with us. So we are talking about some very interesting ways of working on this subject. IoT. I won't talk about too many details about IoT, but 2 or 3 very important things. Very simply, we are in 2015. Most phones will have iBeacon or something like that, so local area connectivity for Internet of Things. That is what is driving IoT at the moment, Bluetooth 4.0. And if you look at 2020, I was speaking at an event in the Mobile World Congress just now, a couple of days ago. If you look at the 5G roadmap, it is 2020 onwards. So if you look at those two dates, then you're looking at basically connectivity both at the local area network and the wide area network between 2015 and 2020 for IoT. And that really is the biggest driver why IoT is going to be big. And IoT is going to be bigger than mobile. When I say IoT, I mean smart devices. It needs to have an identity, it needs to have a radio, it needs to have a sensors and actuators, and then of course there is the context. And I'm going to talk about the context and why that is such a big threat to both privacy and security as a single subject I'm going to mention. Specifically, I'm going to articulate a problem, but not provide a solution to the problem, because the problem is very big. But most people, when they look at privacy and security, they look at one sensor. They look at one problem. They look at smart metering. They can hack into a home and so on. The bigger problem, in my opinion, which is what I'm going to briefly talk about today, is sensor fusion. Is the mixing and matching of different sensors and the implications of what that means. And why that is so important, there was an article in the New Yorker yesterday, I think last week, and it said that essentially when you combine inputs from different sensors and when you can understand what they do, we can track just about any form of emotion as well in people. And that's extremely interesting from advertisers' point of view. So what it can tell you is if a mother and a child are together, they can tell you that there is a mother and there is a child in a shopping mall based on the voice recognition. They don't have to hear the conversation, they have to hear the tone of the conversation. They have to also understand how they are facing each other. If it's the mother and a child, they are facing each other, they know that. They know other context behind that. They know the emotions based on the recognition of your face patterns. Yes. So all of these things, they do not need one sensor. They need multiple sensors. And that's where sensor fusion as a topic is an extremely important topic. I've been tracking this for some time, and also part of my course at Oxford as well. Before I go into sensor fusion, the reason I say mobile is going to be very big, bigger than IoT is going to be bigger than telecoms, is because if you look at the roadmap of mobile phones, the first billion connections was in 2002. 4 billion connections were in 2009, 3 billion connections in 2007, but by most metrics, we are expected to hit about 50 billion IoT connected devices by 2020, and nobody is doubting that number. So what I'm trying to say is that it is bigger than a factor by mobile connections. And the question is, what happens when all these connections are talking to each other and somebody can harvest the interconnections between sensors? So think about not just breaking a specific smart meter, think about all these sensors. They don't even have to know each other. I just have to get data feeds from them, and then I can correlate them back to each other. That topic is called sensor fusion. Yes, and that is the key, one of the key areas we are researching at Oxford. IoT is very big. We don't have to talk about that. But applications like these are very important. So when we're talking about the sort of the Google's robot or even the self-flying drones, all of these require predictive analytics. So all of these, a drone can be monitored by a person, but a self-flying drone needs an algorithm to be able to navigate on its own. And that is why I think all these algorithms are going to be so important. Deep learning is another area which is of great interest to us. So deep learning helps to find out pictures of people, find out patterns in video, and so on. So if I were to look at sensor fusion, now this is a subject which I have taken from two places. One is some things from Freescale, and then a paper which was published about the different techniques of sensor fusion. So if you look at the whole idea of big data, then the big data, actually to get insights from big data, you need lots of small bits of data which are actually connected to each other. So that is a big difference between the IoT data sets and big data in general. So if you look at the classic Hadoop architecture, you need to get everything together in the one place, and then you need to do MapReduce type algorithms and get something. In my case, IoT cases, I am often dealing with streaming data, time series data. I'm dealing with windows of data. I'm dealing with correlating windows of one window to another window. And all of this is algorithmic based. Yes, so all of this is the world we live in, rather I live in, and I'm trying to sort of make with that. And the thing which unites all this world together is sensor fusion, because I'm not really concerned about one data set. I'm concerned about all these multiple data sets which come together, and I'm concerned about trying to find correlations between those data sets and how to do it. There are lots and lots of data sets, both from people, from ecosystems, and also infrastructures and machines. So if you look at a smart city scenario, that's a classic which comes into play there. So what does it mean? So there is one particular research paper now I'm going to talk about. That research paper talks about different techniques of sensor fusion and what they can do. And I'm going to give you a brief example in a robot scenario how that would work. So to do sensor fusion, you have to basically operate at 3 levels, and there is the sort of the estimation. So at the lowest level you have the inputs from the sensor itself, then you correlate to higher level, and finally you correlate to decision level. So there are 3 roll-up points for sensor fusion. Now, if you look at the research behind sensor fusion, there is a few researchers which are doing quite a strong work in this space. The joint directors of laboratory JDL, which is the military application, which is where sensor fusion started in most cases, that has been adapted by a guy called Darthasarthi, who proposed an IO-based architecture, and another one called Luo and K, which is what I'm going to discuss in a little bit more detail. In all cases, so this is the basic diagram how it looks like, and what it really means is that you're taking up from the lowest level, you're trying to correlate to higher levels, and you're applying different algorithms to summarize at different levels. And I'm going to briefly mention the algorithms to you. Kalman filters, if anybody is interested in that area. Anybody is aware of this term? Kalman filters? Okay, good. So, all right, I didn't go too much into detail with that, that's good. So things like those algorithms which are really applying at specific areas to summarize different inputs. And that's what sensor fusion is all about. So sensor fusion means that I can combine anything. I can combine pictures. Yes, from my point of view, 2 pictures are 2 images are sensors. sensor input, I just see them at bits and bytes, I have to combine them into one thing. Now, where that can be useful for is to look at hidden weapons. Yes, so hidden weapons is a concealed weaponry, is a classic sensor fusion technique, because you are combining one set of images, you are combining another set of images, and you're trying to see where there is a overlap or mismatch between them. So there are, like I said, there are three levels. At the low level, there is the signal level. At the second level is called the feature level, and the third level is called the symbol level. The symbol level basically involves decisions, and the signal level involves raw data. So the signal level, if you think about it like either pixels or time series data or something like that, you roll up into something else, which is a medium feature level thing, and then you roll up into something higher, you get decision levels things. So this is the sort of summary slide of the classic algorithms which go along the way. So I won't go into any of these, obviously, but that's the kind of world which would look into sensor fusion. So the lowest level, there is Kalman filters. At the highest level, there is Bayesian analysis, which combines different decisions. At the middle level, there are various cluster analysis and so on. So from my point of view, all of these data sets, they are really different algorithms I'm applying at different points to make a decision. Now, how does this work? Now, if you look at a typical robot like this, which would give you a humanoid robot, which would give you all these inputs. So from my point of view, this is how those robots would look like. This really is what I'm trying to say. That I'm trying to say that there is multiple levels of roll-up to this information before a higher level decision is being formed. And at the lowest level, there is a signal level. At the second level, there is a more feature level. And the topmost level, there is a decision level. And all these three have different sets of algorithms, which I had in my previous slide here. So these are the different algorithms which apply to different levels. And the output of that is a real decision. And what does that decision mean? So this is an example of something like this, which talks about the biomedical scenario or a hidden weapon scenario, which shows you what it means. But all these applications from a sensor fusion point of view are the same. And I talked about, final slide is talked about emotions, and I talked about detecting emotions. In a simple room, you can detect so many emotions by combining sensors, as I show in the slide there. But when you look at a supermarket, when you look at a city, you can apply this into many, many times over. Now, the privacy and security implications of this are very, very deep. I don't think anybody really understands what they are, partly because people are still struggling with trying to understand one sensor problems. They don't really want to think in their mind as to what happens when all these sensors combine together, and they detect everything from emotion to a whole city's behavior in that way. And I think this is what I mean. This concludes what I want to say. I articulate the problem very well. I think the solution is an ongoing conversation. I think what you guys are doing possibly is in this space. And I think there are many other projects also looking into this space. I think it's an interesting space. I really like it because it's not just looking at one particular sensor, but looking at a whole different ways of solving a problem and trying to understand what is possible. I think the possibilities are very high. The good things are very high as well, and as are also the bad things as well. So that concludes my talk. Unfortunately, I have to leave because I have got a flight to catch. So thank you very much for inviting me. And very much, if you follow me on Twitter, I will send you more details, and I blog a lot about these things anyway. So thank you very much. Thanks.